Alright guys, so this is another method, it's called Newton-Raphson method. Before we go for the example, so this is some of the checklists you need to know about the algorithm first. So first of all, your initial point, or it's just the x0, must be reasonably close to the roots so as possible. So sometimes we don't know what is the x0 exactly, but always they give it in the questions. So once you've done this, you start to compute for your your f x0 and f prime x0, and make sure that these two value is not equal to 0. Why? Because I'm saying like this, because first, if let's say your fx0 is equal to 0, that means you don't need to do a calculation. Your x0 already is the roots, so that means you don't need to do that. As well as if let's say your f prime x0 is 0, that means if you look at this this algorithm, so if let's say this is 0, means that it's undefined. So that's why make sure always your fx0 and f prime x0 is not equal to 0. Then you can do for the calculation. So once you have these 2 points, you can start to use the algorithm to do the computational methods or just the iteration. And because this is a formula for the algorithm, basically this is what our new x point is. Take the current x minus the function value for x I divided by f prime x0, and this is your iteration number. So basically it just denotes on which one you are going for. Of course, this is the iteration methods, so that's why we need to know when we're going to stop. So to stop the calculation, they have two options here. So one is something like you take the new point minus the current point. If let's say you get the value is less than the tolerance, then you stop your calculation. Or just simply take the function values, the absolute values. If let's say it's less than the epsilon, then you can just stop in calculation. Okay, alright, so we go through this one, then we go for the example. So this is the example, roughly the example. Do you want to find the roots for the function? Let's say this is function, you want to use the Newton-Raphson methods. With the starting point, this is your x0 initial point, and stop your calculation when it reaches to this tolerance. So basically it's very simple, but first of all, I want you to look at on this algorithm first. So the function that I need here is the function fx as well as the f prime x. So that means I need to do the differentiation, differentiate this function, I get this one. So once I have this, I do some cross-checking first. I want to check my x0 whether it's equal to 0 or not. So when I do the cross-checking, but I notice that the f x0 and the f prime x0 is not equal to 0, that means it's good for me to use the iteration formula here. So to begin, it's very simple. We start with the I equals to 0, and this is your initial value for x. Basically, you just take the x equals to 0.8, this one, 0.8, and then enter. Then your fx, basically this is your x formula, is the exponent, so it's the exp bracket. Your x, meaning that this is your x0, your x value, minus 2 over x, your x is here, enter. And this is what we have here. So you can see the formula, you can check the formula whether it's correct or not. And then next, you can do for the f prime x0, because this is the f prime x. So that's why this is the exponent x, this is exp exponent plus 2 over x squared. So this is your x, close bracket, power of 2. And this is what I have here. So then what I did here is I take the value for x divided by this one, divide by this, and this is what I have here. So why I do why I create this column, basically I want to tackle for this algorithm formulas here, so it's easier for me to do the calculation from the next loop and the following loops also. So how to get this one? So basically you just take the absolute value for your fx here, then enter. So this is your absolute value. Obviously this is not yet reached to this value, so that means we need to continue for the next iteration. So for our new I, so basically we can take this formula. So basically it's just the current I minus the fx divided by f prime x. So basically you take this value only. So that's means you just select this one and then enter. So this is a new value, and because of that, so this is another one. So this is another beautiful of when you're using the numbers. So basically you don't need to do to key in again the formula basically, because what I'm saying like this, because this formula we already key in for the first loop. So basically we take this value to do the calculation to get this one. So what I can do here, I can just simply highlight this thing and then drag over here, and I get a new point over here. And this is somehow like the calculation. You can just proceed for the rest. So like this one, you can just simply drag and you get the answer. Wow, so fast. You can get the answer. And basically you see that, so once you finish the loop number 1, loop number 2, so the absolute value here is already giving you as a 0, 0, 0. That means this is your calculation answer for the Newton-Raphson method.